This week, we're going to be covering the 70-second LeetCode problem, edit distance. This is a super popular LeetCode question. I was actually asked a very similar version of this in my Google interview as well. So it's safe to say that this is one of the hard problems in LeetCode that tends to get asked many times in interviews. Let's dive right in. Given two words, word 1 and word 2, find the minimum number of operations required to convert word 1 into word 2. So you have the following three operations. You can insert a character, delete, or replace a character. So the minimum number of operations required to convert horse into ROS is 3. We can replace H with R, remove R, and remove E. Now here is another example. The minimum number of edits required to convert word 1 intention into the word 2 execution is 5. And these are the operations that can be performed. Cool. Now let's jump into the algorithm that will help us solve this problem.
I think the best way to understand how to solve this problem is with multiple examples. Say that we have string 1, which is MIC or Mike, and string 2, which can either be empty string, M, MA, MAT, or MAC. And the reason I have so many string 2s is because the best way to learn is just going to be to go through the examples. So let's say in our first example that string 1 is equal to Mike and string 2 is just an empty string. How many different inserts, deletes, or edits are we going to need to perform to change S2 into S1? So here we have an empty string and we have Mike. Mike this way, empty string this way. If both of these strings were empty, we would need to perform 0 operations. Now, because S2 is empty and S1 is not, we're going to have to continue to iterate through this matrix and fill it out to understand how we can change S2 to S1. So in this case, it's empty, but to change an empty string to the word M, we're just going to need to do one operation. Now, if we want to change the empty string to MI, we're going to need to do 2 operations. And if we want to change the empty string to C, we're going to need to do 3 operations. Those are just going to be 3 inserts. Now, suppose that string 2 to be M. How can we convert M into MIC? So initially, we're going to need to fill out that we know that we have an empty string here, and we have one string here. So it's just going to be 1. So if S1 was empty and S2 is M, then we're going to need to take one operation to convert S1 to S2 or S2 to S1. Now, here's the interesting part. If S2 is equal to M and S1 is also equal to M, then we're going to need to do 0 operations because the strings already match. Now suppose that S2 is M and S1 is MI. We're going to need to at least insert I to S2 or delete I from S1. So that's going to be 1 operation. And of course here we're going to get 2. Moving forward, if we have string 2 to now be MA, so now we have MA. We know that if S1 is empty and S2 is MA, we're going to need to do 2 operations. If S2 is MA and S1 is M, then we're going to need to do 1 operation. If S2 is MA and S1 is MI, we're going to again need to do 1 operation. And if, of course, if S1 is MIC and S2 is MAC, then we're going to need to do 2 operations to convert MA into MIC. The second word is MAC and the first word is empty string, then it's just going to be 3. Now again, we have CM and this is just going to be 2. And if we want to convert MI to MAC, that is again going to be 2 operations. And if we want to convert MAC into MIC, that is going to be 1 operation. So let's just take a look and try to understand this matrix. So there is one base case that we're going to need to think about, empty string base case. So in both base cases, if the first string or the second string is empty, we want to just fill out the initial row and the initial column with just 0, 1, 2, 3, 0, 1, 2, 3, however long the string is. The second case is if the characters are equal. So in this case, when we are comparing M with M, which is this IJ pair, because they're equal, all we want to do is get the I-1, J-1, and move it over here. Now, if they are not similar, take the minimum of these 3 values take the minimum of these and add 1. So the minimum of these three is 0, so we add 1 here, and that's what we get here. So, and C is not equal to M, so we're just going to take the minimum of these and add 1. So what I'm trying to get at is that there's two real operations to consider. So in terms of big O time complexity, easily we know that it's going to be n squared time and n squared space. We have to create a matrix that is the size of the string multiplied by the size of the second string. So if both strings are of size n, then we're going to have an n squared matrix. And of course, we're going to need to fill out every single row column pair and return the final value, and filling out every single row column pair is going to take O of n squared time. So the time complexity is pretty straightforward. The difficult thing is going to be understanding the algorithm. I hope it was a little bit clear. We'll go into the coding section, so if you didn't fully understand it, maybe this will clear things up.
Now that we went over the algorithm and the big O time complexity, let's look at the code. So we have to initialize our matrix. The matrix is going to be of size length of the word 1 plus 1 and length of word 2 plus 1. So we're going to need to fill out our base case, which is the case when the first word is empty or the second word is empty. Afterward, we're going to iterate from the first column and the first row, the first row and the first column, and we're going to go through the length of the entire nested loop. Now, it is a little bit confusing because we have to keep track of which word represents the column and which word represents the row. But that is something that is just going to take a little bit of thought, and when you're coding the answer, you just have to think about where you place the word. So that's like not necessarily too difficult, but it can get a little bit confusing. So the main two cases that we want to consider are these two cases. So if the character matches when we are in a specific iteration of the ij pair, then all we have to do is say that the current value of the ij pair is equal to the i-1 j-1 pair. Otherwise, we are going to take the minimum of the three matrices, of the three values in the matrices, which is row -1, column -1, and row -1 or column -1. Take the minimum one and add 1. So that is going to fill out the entire matrix for us. And in the end, all we need to do is return the length, or return the bottom right hand corner value. And that's going to contain the minimum edit distance it requires to convert word 1 to word 2 or word 2 to word 1. So let's just run this code and make sure that it works. Now, it is not fully optimized. I do portion out certain things that could have been done inside of the list comprehension itself, things like that make it run a little bit slower than it needs to, but it is not a big deal. Hope you guys enjoyed this video. Leave a like if you did, and subscribe for more in the future. I know that it is going to be Christmas and New Year's, so hope you guys enjoy your holidays if you celebrate, or just have a great New Year. I'll see you guys next time.